our previous video, we discussed the basic concept of Guénon's notion of quantity and quality. Here, we will be looking into one of the many ignored books written by Guénon, which is his treatise on the metaphysical principles of the infinitesimal calculus and the notion of infinitude as a metaphysical principle in general. The infinitesimal calculus can be understood as the arithmetic study and observation of infinite change, flux, and/or repetition. This book has many chapters, but for the sake of brevity today, we will be focusing on what I believe to be the most important concepts within the book itself. That being said, we will cover chapters 1 through 4, 6 through 8, 12 through 15, 16 through 18, and finally 20 through 25. Chapter 1. The Infinite and Indefinite. Beginning at Chapter 1, we are introduced to the concept of the infinite and indefinite distinction, which will lay the groundwork out for the rest of our video here. Guénon states that the concept of the infinite is similar to the indefinite but not identical in any ontological sense per se. The infinite, as such, is something which we do not have access to in an epistemic sense because of the human disposition of being finite. Due to this, we can only know the infinite in a lesser sense, which is to be called the indefinite. Now the question arises as to what the distinguishing factor between the infinite and indefinite is. The factor that makes these two distinct is that according to Guénon, the infinite is completely unbounded, as that is what it means to be so. The indefinite is bounded by the fact that it manifests itself within the corporeal and temporal domain of being, but it expresses itself as a continuous and quote-unquote infinite in the sense that through its corporeality, it is continuous and never reaching a limit outside itself. For example, the notion of numbers is an indefinite one, because while it may be the case that there is no set amount of numbers, these numbers cannot cease to be numbers ontologically, so they are, in a sense, not completely unbounded. The number 3 is always the number 3, but it is in the sense the number 3 infinitely because of the fact that it cannot escape its identity as being such. The repetition of numbers, while everlasting, is limited by the fact that they are determined to everlast in a particular way, so they are infinite within a bounded setting. What both these concepts of indefinite and infinite have in common is that they are everlasting and unbounded in some sense, the latter being unboundedness as such, while the former being unbounded in a bounded setting. It must also be noted here that within this chapter, Guénon does point out that attempting to define the infinite is at best a rough understanding of what it actually is, and this is because of the fact that to define something is to limit it, and the infinite by definition cannot be a limited category. So because of our finite understanding of the infinite, the best we can know of is the indefinite, which is downstream of the true infinite. So since space, time, and number determine ontologies, that's what makes them indefinite as opposed to infinite. Chapter 2. The Contradiction of Infinite Number. Following on from the distinction made in Chapter 1, we see that the notion of a quote-unquote infinite number is also subject to error insofar as numbers are, as we have mentioned previously, limited ontologies. While they may be everlasting in quantity, they are still determined to be numbers and signifiers of the realm of quantity, which is itself determined. One can say that numbers are indefinite as they possess an aspect of an everlasting nature, but once again, because they are fixed in identity and limited by their identity as numbers, they cannot be considered to be infinite. Within this chapter, Guénon also speaks on the issue of the notion that there is some quote-unquote infinite number, or number that trumps all other units in quantity. Now this can't be considered to be infinite because, as we have already established, the number as a category cannot be infinite as it is a rigid designator, and it picks out a strict identity which is bound to itself in order for it to have its identity. Furthermore, one cannot even state that the notion of a quote-unquote infinite number can be understood when redefined to be an indefinite number, because if something is indefinite, it does not terminate in any regard, and one number that is superior to all numbers implies a terminating point. So if anything, this theoretical number could only be called a ultimate terminating one, but this is of course not possible because there is no logical incoherence with the indefinite continuum of numbers, as I can always stack units. So long as that exists, it must mutually exclude the notion of a terminating number, since both cannot exist at the same time. If it was the case that an ultimate terminating number did exist, then we would see that there would be an issue with the law of multiplication, because one would not be able to multiply the ultimate number because its very nature wouldn't allow for it. Yet we don't see any logical issue ever with multiplying numbers, and nothing logically speaking suggests that multiplication has its limit with this certain number. If I choose to add or multiply any number, it does not lead to contradiction or metaphysical impossibility ever. This is not an empirical thing either. This is not an issue where we need to observe natural phenomena and then come to a basis via induction. Rather, it's one of reason alone. where we deduce what is true from the axioms of mathematics and logic in general. Number in the way it is understood today only applies to the domain of existence that we understand as quantity. And the issue with this modern outlook on things is that it seems to believe that one can reduce all things down to number, when in fact number being a limited thing must be limited by something outside it, and if something is limiting it, then something more fundamental than number exists. Chapter 3. The Innumerable Multitude. Leibniz rejects the notion of infinite number, but does not object to the notion of an infinite multitude. Guénon points out that in order for him to think this to be the case, he must reject that multitudes are numeric in nature, because if they are numeric and numerals can't be infinite, then that which is composed of numerals must also not be infinite. It is, though, in a sense true that there is a notion of multiplicity which transcends the quantitative. For instance, we can speak of the multiplicative aspects of God. In this text, Guénon uses the specific examples of angels, and how these beings exist in a non-quantitative realm, yet they are distinct beings. Even though it does transcend the order of quantity, multiplicity as a category is applicable to all domains of being, as there exist different modes of quantitative/material being. Number itself can also be understood to be a form of multitude because of the distinct kinds of numbers that exist. Guénon also points out a flaw with Leibniz, which is that he does in fact consider the infinite multitude to be made up of units, and Guénon here states that this can only be understood in the quantitative realm because units are proper to that realm. When the notion of units is spoken of in the plural sense for Guénon, this is meant to designate the realm of quantity, as units are proper to this. Whereas if we speak of unity as such, that is equated with pure being. What leads more credence to the belief that Leibniz is speaking of numerical units is because he is speaking of the sums of these units, and sums presuppose composition, which is quantitative. Leibniz also states that the infinite does not constitute a whole, but this is because he has the wrong notion that the whole is the sum of its parts, which is proper to quantity, rather than the whole is the metaphysical unity of being. Leibniz is actually correct in saying that the infinite can't be understood as the whole, but this is only because his notion of the infinite is really a flawed one, in which the notion of the indefinite would properly suffice. Leibniz reduces infinity down to a number, so fundamentally this is where his issue stems. Guénon also mentions that the quantitative whole versus the qualitative whole is something modern thinkers neglect. The whole which Leibniz speaks of is one in which, according to Guénon, we impose a unity upon, when in reality it is a mere collection of units, and the quote-unquote whole here is contingent upon its parts. The real whole, in principle, is one in which the unity is logically prior to its multitude, and the parts are contingent on the whole as such. To recap, this chapter is titled The Innumerable Multitude because the notion of multiplicity is not exclusive to either quantity or quality, rather both. Chapter 4. The Measurements of the Continuous. Guénon starts out this chapter by denoting that the notion of whole number is the only true sense in which numbers can be understood. This is because whole numbers are understood to be pure numbers, and one may rightfully ask about fractions and decimals, but these two can be understood to be made up of whole numbers as well. In the case of, let's say, something like 2.5, the 0.5, which is the halfway mark to 3, can be understood to be made up of 5 number ones inferior in proportion to the 2 preceding the 0.5. Guénon here also points out how whole numbers should not be able to be divisible, and this is because since whole numbers are without parts, they cannot be divided into anything. They are abstract universal entities, so therefore they cannot be divided. Fractional numbers only make sense in the context of the measurements of geometric magnitudes, which, because magnitudes can be indefinitely divided, this is where the notion of the measurement of the continuous is considered. The notion here of division does in fact work because we here are concerned with things that do have parts, which are magnitudes, because it is within the domain of quantity. We also see a strange issue with number lines, which is the problem of the indefinite interval between any two numbers. For instance, between 1 and 2 there are an indefinite amount of fractions between them, which can never cease to be. The main point of this chapter is to show that the notion of number as continuous is not a sufficient enough ontology to describe the notion of continuity as a principle. Here, Guénon uses the example of irrational numbers, which, while they are everlasting, are determined quantities, so in a way not truly continuous. To represent a continuous quantity, it would be more accurate to use variables such as x, since this shows that they can be anything and are not fixed quantities per se. Chapter 6, Well-Founded Fictions. Here, Guénon touches once again on Leibniz's notion of the infinite quantities as well-founded fictions, and he described Leibniz's notion as, according to him, not complete fictions, but notions that are reasonably true. What Leibniz means by this is that these infinitesimal quantities are found within nature and therefore reflect reality in some manner, so to speak. Guénon asks, if these are well-founded fictions and they occur logically within geometry and nature, why does it make sense to call these things fictions whatsoever? This notion of fictionalism within the early modern sciences is what gives birth to the modern notions of fictionalism within modern science. The question still remains for Leibniz, though. Why introduce these fictions if there is no logical incoherence with indefinite continuity? One can always add another unit to another, so why is this a problem? According to Guénon, the use of proper terminology would have prevented a lot of these hermeneutic issues within mathematics as we understand it today. For instance, instead of calling units infinitely small, it would have made much more sense to refer to them as indefinitely small, since quantities are, as was outlined in Chapter 1, determined continuum. Since the notion of the indefinite implies becoming and change in variability, it would have perfectly fit the process of the indefinitely small reduction of numbers or their increase. Once again, Leibniz is right for the wrong reason when he speaks of the infinitesimal as a well-founded fiction. He is only right because we can replace the infinitesimal for a more accurate term, which is the indefinite, since when engaged in mathematics, we can only understand the indefinite when dealing with quantity. Leibniz, because of his failure to distinguish between the infinite and indefinite, is wrong when speaking of continuity as a well-founded fiction. Chapter 7, Degrees of Infinity. This chapter here starts out by pointing out how the confusion among the late Middle Age philosophers arises from a lack of understanding of metaphysical principles as outlined by the ancient traditions. We also come to learn in this chapter a surprising fact, which is that despite Leibniz's mistake, he was able to distinguish between the infinite and interminable. For some reason, according to Guénon, Leibniz cannot distinguish between eternity and duration, which gives rise to Leibniz's notion of the terminating eternity. Guénon counters this by saying that eternity, as they understood traditionally, is relative to a certain context. For example, the traditional cyclic time model is one of eternity, but it has within it terminations, but these terminations are only relative and not true terminations per se. Nonetheless, these modes of eternity are to be understood once again as indefinite since they are contextual to the realm of quantity, but it should also be noted here that these time and spatial notions do of course have a qualitative aspect which will be addressed in the next video in this series. Next, we come across Leibniz's notion of the degrees of infinites, leading to the supposition that there are worlds infinitely smaller and greater than our own, and with all things in proportion to its inhabitants like our world. Guénon raises the question that once again these worlds cannot be designated as infinite because they are limited in the sense that they have a strict identity making them indefinite. One may also even ask why these should be considered different worlds, when they could just be extensions of the same world as they follow the same law of speciality and exist at the same time as the other worlds. The indefinite amount of worlds can be something which is possible, since this notion allows for a continuous multiplicity, but understands that it takes place within a fixed context. The main issue here with thinkers like Leibniz, according to Guénon, is that they take traditional and primordial truth and distort its real meaning. For example, he uses the idea that Leibniz has, which is that of the quote-unquote best of worlds, which is a world with as much being and reality as possible. He borrows this notion from ancient geometry, which states that a circle with a circumference that can contain all line segments of equal length is the world which is the best of all worlds because it is a maximum world. Chapter 8, the quote-unquote infinite division or the indefinite divisibility. Once again, Leibniz is referenced in his notion that bodies are infinitely divisible and that while they may not be divided in actuality, they possess the potential to be divided infinitely. Jean Bernoulli, His philosophical adversary, on the other hand, asserts that in order for things to be infinitely divisible, they must possess this multiplicity already in actuality. Much like his, Bernoulli's, notion that an infinite sequence, when given, must contain all the units that make it up. Thus, we are faced with a infinitesimal limit, which is a contradiction in terms. It is a contradiction because when a infinite sequence is given, it does not make sense to give all of its terms because the notion of all implies completion, which it is of the very nature of the quote-unquote infinite not to possess. But because for Bernoulli it is impossible to divide numbers infinitely because the infinite elements don't exist in actuality, it is thus the same issue in nature concerning matter. Since these infinite elements don't exist in the extension of matter, there is no reason to believe it is divisible infinitely. Furthermore, Guénon points out how there is no logical contradiction when dealing with the divisibility of matter to state that it is indefinitely divisible and is logically coherent because just like numbers and fractions, you can always increase or decrease the units. Atoms, as understood to be final elements, do not exist because just like in the mathematical world, you can always divide by ever increasing fractions without running into a logical problem. Now, for the aforementioned reasons, throughout this video, it is pretty easy to guess that Guénon will not be keen on using the terminology of infinite when speaking of division. He much rather prefers indefinite. He also points out that, yes, all matter is infinitely divisible, or indefinitely divisible rather, but not because it is material, but because it is extension. And I'm not sure why this is the case. This is just something he is presupposing here, but it does seem that it has something to do with the false Cartesian notion of matter, which maybe he has elaborated on elsewhere, I'm not sure. But because the very nature of extension is to be divided, there cannot be indivisible extension, because if this was possible, it would have to be extensionless. On the topic of division here, it must be also noted that Guénon states that the parts of a composite whole must retain some likeness or homogeneity to the whole itself. We must also understand that because a whole has its parts, it does not follow that the parts we believe to be of the whole are in fact the actual parts of the whole. Often we impose our notion of parts to a whole which may not actually be the authentic parts of the whole according to Guénon, or even we will create a whole that does not actually exist. It must also be noted here that all units within an indefinite sequence cannot be given distinctly, as this would once again contradict the essence of the indefinite sequence. While Leibniz does get many things correct, namely his notion of interminability, he must be corrected in that interminability is to be understood as indefinite, and his notion of the infinite division of matter must be understood as the indefinite division of extension, because matter is a determined quantity and has a strict identity. As such, it can only be manipulated in an indefinite way when speaking of the continuous. As mentioned before, the division of matter must be understood to be the division of extension because according to Guénon, the notion of matter today is problematic due to its Cartesian roots, and extension is a more exact and rigorous term. Chapter 12. The Notion of the Limit. Guénon here explicates that the notion of the limit is one which is logically necessary within the realm of mathematics, in particular calculus, because you cannot have the indefinite increase or decrease of units without limitation. The reason is because numbers are limited in the sums they reach in terms of identity. For instance, 1 plus 1 makes 2 always is the case, even though we can keep adding more numbers to it. Variable quantities can never reach their limit, as while they may be determined in identity as variable and as a quantity, they can be anything, so it doesn't make sense for them to reach their limit if their nature is to be variable. It must also be noted here that while quantities can indefinitely decrease, they can be no less than 0. For a quantity to be infinitely small, they must be a quantity, and 0 is the lack of quantity. When defining the limit, according to Leibniz, it must be defined as something which variability cannot reach. Variability cannot reach the limit because if it does so, it ceases to be variability, as the limit is by definition a fixed thing and variability is not. Guénon states that it is no surprise that many mathematicians reject this notion of limitation because here Leibniz introduces a qualitative difference into a quantitative field. If, according to Guénon, one is to reject this notion of the limit because of the qualitative nature of its definition. What makes it qualitative, by the way, is the very fact that the limit can't be reached, therefore quantified. One must also reject the notion of similarity within geometry. One must do so if they are consistent, because similarity is the qualitative aspect of geometric forms, and we know this because it is independent of the magnitudes of the forms, which is a qualitative determination. This is why we can see large triangles and small triangles, because they possess similar qualities while possessing different quantitative determinations, which in this case is size. Chapter 13, Continuity and Passage to the Limit. In this chapter, we see a critique of Leibniz's notion of continuity from Guénon. He, in his definition of continuity, defines rest as another form of motion, but an exceedingly small form of motion, and he defines the equilibrium of bodies as vanishing disequilibrium, but at the same time a form of inequality. Guénon rightly points out that this is a contradiction, plain and simple, as you are defining a property by giving it the qualities of what it is not. Guénon uses the example that Leibniz gives, which is basically that a regular polygon which becomes limited in the indefinite sides of the circles is the same thing as the polygon. Fundamentally, this lack of ability on the part of Leibniz to see the qualitative distinction between the limit itself, in this case the indefinite sides, and the thing being limited, in this case the polygon, Guénon states finally that when comparing two exclusive differentiations or genus, we can only compare these things by what they have in common and not in how they differ, and what they have in common allows them to be part of a higher genus. A higher genus because genus itself presupposes differentiation, since when things are listed under a genus, they are being compared, and you can only compare things by what they have in common plus their specific difference, which allows for the comparison of two separate things in the first place. For example, if I compare a dog and a cat, in order to compare them under the genus of mammal, they must have things in common, such as fur and the ability to breastfeed. But the act of grouping the cat and dog under this title of genus requires them to be different in some way, because to compare two separate things is to say that one thing is different from another. Now, and they also must have something in common. Now, he ends this chapter by stating that if we have a conception of continuity where the abolishment of one genus to another is not through the unification by a higher genus, then we here are left with a contradictory property. And this then, according to Guénon, leads way to the Hegelian notion of the identity of contradictories, where the actual identity of an object is to be self-contradictory. Chapter 14, quote-unquote vanishing quantities. The basis of the passage to the limit for Leibniz is the notion of vanishing quantities, which makes sense since according to Leibniz there is no ability for quantities to reach this limit. And if you have an infinite amount of quantities, they in some sense must vanish, but he also holds that they cannot turn to zero, but must still be something. Leibniz holds this position that the quantities within the law of continuity must be vanishing, because in order for them to actually remain in a state of continuity, they must not be impassible. But at the same time, they cannot be nothings, because in order for them to continue, they must be multiplied in some sense, and you can't multiply nothing. Guénon notes that if this is the case, that these quantities vanish and are null, but not really so, but at the same time we need to treat them as if they are, then what difference does it really make? Guénon ends this chapter by saying that the notion of quote-unquote vanishing quantities can't in any sense lead to continuity, since that which does not exist in actuality can't be none other than nullified and have no effect on the corporeal world. It leads to a contradiction to say that null quantities are the basis for the interminable continuity, because what is continuing if something is being negated in the process? That doesn't make sense. Leibniz attempts to fix this by saying that it is not really that they are negated, but this doesn't really solve the issue at all, because all it does is just show his conceptions are incoherent. Chapter 15. Zero is not a number. It is stated that just as an indefinite sequence can never end in an infinite number, or indefinite number, It can't end in a null number either. For the first and obvious reason that it is opposed to the nature of the indefinite to end. The fact that we can indefinitely reduce numbers or increase them would also require the introduction of new types of symbols to represent these notions. For the indefinite increase, the classic symbol used to represent quote-unquote infinity would suffice, and logically speaking, to show infinite reduction, the 0 would also suffice because it is missing the other half, which shows it is going in the opposite direction of the indefinite increase. 0 is not a number because number is proper to the domain of quantity, and the lack of quantity in itself or the negation of quantity as such can in no way be considered a quantity. For one to say 0 is a number would be for one to say that non-being is being, which is in itself a contradictory statement. Furthermore, if one is to look at 0 as an infinitely or indefinitely small number, it leads to the logical conclusion of its inverse, which is a infinite or indefinite number, rather, which is no less contradictory. The indefinite reduction of quantity is also taking place within the realm of quantity, for how could it be other than the name implies? Now, Guénon states that while we are not able to conceptualize the indefinite increase in numbers as a quote-unquote infinite number, we can still represent the indefinite with the classical sign used for the infinite, which again is also a misnomer because the infinite is something beyond the realm of quantity. Anyhow, the sign of the infinite is classically known as the horizontal figure 8. This symbol does not represent an infinite or even indefinite number, rather it represents a indefinite domain of numerical variability, which is basically what continuity is. Mathematics, as it is known today, lacks a symbol for the indefinitely decreasing. The solution to this, Guénon states, is to take 0 and reinterpret it to mean indefinitely small. So when given a number line with points in between, on the right side we have the horizontal figure 8, and on the left side we have the 0, but this 0 represents not a indefinitely small determination, but rather, like its inverse, a indefinitely small domain of numerical variability. Speaking in terms of the logic of mathematics, Guénon states that 0 came to be understood as a nullifying number, as it does so in the process of calculation, such as 3 times 0 equaling 0. But he says that we need to reinterpret this. So I would assume here that what he is saying is that when we multiply 3 by 0, it can still produce 0, because what it is what you're saying, that 3 multiplied by an indefinite decrease can only go in the direction of a indefinite decrease. We can also multiply 0 by the indefinite according to Guénon, because this will simply just represent indeterminacy. So therefore, the two symbols being multiplied are equal to the variable n, which can be any number as it is a variable. This is what we would call an indeterminate form, because the form of the number varies as it can be any. Now, of course, the variable n, which n represents, if it is to adopt a number, then it becomes finite through the mediation of the two indefinites. I suppose one can think of the multiplication of the two as a machine that is going to spit out any random number, be it whole or fractional, because the two indefinites contain any number. We must also remember that the symbol being used does not represent the infinite because of the numerical determinacy of number, but also because the infinite can never have within its opposition or correlation, because it accounts for everything, even non-being. Guénon states here once more that 0 as a symbol can be used to represent non-being, but it should be noted that it is absolutely distinct from non-being as such, which is what 0 is often mistaken for. 0 is impossibility, and therefore can't ever be accurately represented by anything, because a thing which represents the nature of impossibility of existence is itself a possibility. So that's a contradiction. And we also come across another contradiction within the realm of modern mathematicians. As it's pointed out here by Guénon, that if modern mathematicians take 0 to be pure nothingness, then why do they add it to the end of numbers to represent a indefinite increase, for example, 10, then 100, then 1000, so on and so on? How can the addition of the symbol of pure nothingness be something? Chapter 16. The notation of negative number. Given both definitions of zero, the original being understood, albeit falsely, as pure nothingness, and the new revised one created by GUENON, in which zero is understood to be a symbol representing the indefinite decrease of quantities, in both of these cases, the notion of negative number has no logical basis either. In the first case, where zero is understood to denote pure nothingness, there can be nothing less than nothing. It is not possible to remove non-being from non-being because the act of subtraction presupposes a thing which is being subtracted, and you can't subtract no thing. Furthermore, when introduced with the revised and proper definitions according to GUENON, there can be no number less than zero, as zero now is symbolic of the indefinite decrease, and no number can be the smallest indefinite number. We also cannot start from zero and pass on to other units, if we take zero to be pure nothingness, because to start also logically entails a place at which one is starting, and if it is a place, it is something and not nothing. You also cannot pass from zero to a unit of quantity, as since you are starting in a place of non-being, or lack of actuality, you can't have any potency to move forward. Like zero, negative numbers can also be reinterpreted in the sense that instead of the negative symbol representing that which is beneath pure nothingness, it is rather representational movement in the other direction, at least in the case of magnitudes, where the negative and positive denote magnitude in the opposite direction, while the origin is what determines these directions. The negative and positive signs attributed to the numbers on each side of the number lines and magnitudes are qualitative in that they don't represent a change in the nature of the amount or quantity of a number, rather they simply show a change in direction. Since the lines are indefinite in both directions, we could apply the negative and positive symbol to it, but it also must once again be understood that it is not something which is infinitely less than zero, because if zero is pure nothingness, then you can do nothing to it. Rather, it is indefinite in the opposite direction of the positive. The negative indefinite, in this sense, is not indefinitely small, because in the case it is an increase in the opposite direction and not a reduction. This conception only applies when we are speaking of spatial and temporal magnitudes, as in the case of pure arithmetic, which is an immaterial endeavor. There is no direction, only reduction in form. Number has both a qualitative and quantitative aspect to it, as it is quantitative in that it represents an amount, but qualitative as in there are differentiations of them, and they are universal and immaterial ontologies, which because of this we can say that since there does not exist an indefinite amount of immaterial universals in the category of number, it is also the same in its quantitative aspect, as it is a reflection of the higher up. We are not dealing with the reduction of extension purely. Chapter 17. Representation of the equilibrium of forces. We see a digression in this chapter from GUENON, where he now introduces to us some of the principalic problems with modern mechanics, which for this video we're just going to call physics. They are in fact related because mathematics is the basis on which theories in physics are developed. The principles in modern physics can only be called such loosely speaking because they are in reality approximations and not principles. The principle of inertia is cited here as an example of a flawed notion of principle because it takes the universal principle of potentiality known by the scholastics and degrades it, as all it is doing is applying this principle of potency in a particular manner to certain situations rather than as a whole universal metaphysical claim. Here we also see GUENON talk about the notion of vectors, which is the basis for the equilibrium of forces, because the definition of a vector is two line segments equal in equal length aimed in two opposite directions. This is typically represented by two coefficients with opposite signs to denote the movement in opposite directions. If the two forces are of the same intensity, they are equal in value, and if we are then to subtract them, we get zero, which is regarded as pure nothingness by modern mathematicians, which then leads us to conclude that their state of equilibrium is non-existence. This is absurd, as equality can only be applied to things in existence, not the other way around. Now, according to Guénon, this false notion of the equilibrium of forces must be replaced with a revised and proper one, which is to say that forces are either of contraction or dilation. So long as there is contraction, there is dilation. They cannot exist without each other. How can something grow if it does not start out from a more contracted and smaller state? Now, when these forces of dilation and contraction work on one point and meet, so to speak, uh, they will not produce either contraction or dilation. These two forces are not equal in this instance, as they still remain distinct forces, but they will be sublated not into the coefficient of zero, since this would be to say they become nothing, but rather into one as they become a single homogeneity, even if it is a stasis. This state of equilibrium is anything but non-being. As for something to be a state, it presupposes being, and this is what according to Guénon is considered to be the activity of heaven, where the primordial state is one of equilibrium. I will touch on this primordial state in a future video about Guénon's notion of space sublating time. Chapter 18, Variable and Fixed Quantities. We return once more to some of the issues with Leibniz. Namely, we return to the notion that the quote-unquote infinitely decreasing is not absolute nothingness, but some sort of nothingness, which is not really saying much. This vagueness leads to the conclusion that calculus is nothing more than a vague endeavor that's not really rigorous. An indefinite decrease can only be a decrease between two variable quantities and not two fixed ones, because it is of the nature of the indefinite to be variable. When calculations take place, it is the case that only one can pass from variable to fixed quantities, as the indefinite variable quantities are in a mode of becoming. They do not lead to any results or terms, so only fixed quantities can be understood as terms. It is a passage to the limit, but not in the sense that Leibniz understands it, because variation is not terminated. Rather, the fixed quantities within variation are brought to rest in the result of a calculation. Because of Leibniz's false notion of continuity, he is not able to see that a passage to the limit implies discontinuity, because that is a false ontology form. A indifferent difference can never be nothing, since it is the difference of variable quantities, while the difference of fixed quantities can be nothing. But I'm assuming here Guénon would say we should not, of course, represent this. The difference between indefinite variability and fixed quantity is qualitative, and that when in comparison you are not comparing amounts per se, but rather the nature of number to potentiality of number, which is variability. Chapter 20, Various Orders of Indefinitude. Often, in mathematics, the notion of multiple infinities is brought up, especially when speaking of magnitudes, as the differing dimensions of space within these magnitudes are considered to be infinite to various degrees. For the obvious reason, we will not consider any attribute of a magnitude as infinite, because these magnitudes are fixed in identity and belong to the realm of quantity. Similarly, the notion of infinities being greater than another is also absurd, because it is akin to saying there can be multiple absolutes, which by definition of the absolute there can only be one. We also find another contradiction among the contemporary mathematicians, which is to say that the finite can contain the infinite. An example would be the notion of a sphere containing all circles within it. How can the bounded contain the unbounded? It can only logically work the other way around, where the unbounded can inject itself into the bounded, thus preceding it and containing it. Now, because of what it means to be indefinite and not infinite, there is no logical contradiction in saying that various orders of the indefinite exist. Magnitudes can possess multiple indefinites, as indefinites are a determined continuum. As Guénon established previously, the presence of negative and positive numbers indefinitely increasing in both directions is an example of this. Once again, since we are making our way closer to the end of this book, I'd like to reiterate that what distinguishes the infinite from the indefinite is the fact that the infinite is the universal and unbounded all, and the indefinite is merely a continuum, which is determined to be such and consists of determined quantities fixed in identity, but in totality the indefinite is contingent upon the unboundedness which we call the infinite. The multiple indefinite orders must be in nature variable, because that is what it means to be indefinite. Chapter 21, The Indefinite is Analytically Inexhaustible. A quantity of any given order can be considered to be a sum of an indefinite continuum of numbers, as any number possesses any amount of number, as it is divisible into an indefinite amount of fractions. Due to this, one must say that the indefinite is by nature inexhaustible. Another phenomena appears, which is that due to the nature of the indefinite, one cannot say that any of its variables really can affect a sum of fixed quantities, because it can be also reduced and never get us to this fixed sum. This here echoes Zeno's paradox. Anyhow, when one wants to affect this sum, it must be so in a way of what Guénon calls quote-unquote integration, which is to say, numbers are brought together at one stroke, irregardless of their indefinite elements. When speaking of indefinitude, the arithmetic sum is not applicable because we here are focused on the passing of quantities that are fixed in identity onto the next. The nature of the indefinite being variable thus makes it inexhaustible, which in turn does not make it analytical as such, and only via synthesis of the fixed quantities within the indefinite sequence can one get some notion of continuum. The fact that any quantity or sequence of quantities can increase or decrease indefinitely means that one cannot analyze it, since it has the potency to have all possible numerical values, and only through integration, which is the disregard for the indefinite elements, can we come to understand some of the sequence. For example, 1, 2, 3 is a sequence if one wishes continues on indefinitely. But in between 1 and 2 lie an indefinite amount of various values, so in order to have a mild analysis, I must disregard them for the time being, although they still exist. This is in a way a testament of Zeno's paradox, but has the solution for it, which is the recognition of potency. Chapter 22. The synthetic character of integration. Integration is a synthetic process, as it is the passage from one number to another, while an analysis disregards all the indefinite elements of number, but in practice accounts for them by acknowledging their existence, all while skipping them directly and rather containing it in the passage. For example, when one calculates the sum of 1 and 2, we start with both these numbers, and while we don't account for all the variable and indefinite elements, it is through presupposing their existence that we can engage in such actions of calculation. When we take a discontinuous sequence, let's say something like 1 through 4, the sequence, as it is bounded by the two terms 1 and 4, is not indefinite itself, but it does in a sense have a form of a indefinite nature, in that in between the two bounding terms rests the indefinite decrease of values. So from 1 to 4 I can say 1, then 1.0, 1, and so on, and keep reducing it at the level of 1 if I so desire. The indefinitude in the continuous set is present in its very inner nature, which is variability. When we are given any set continuous or discontinuous, we must understand that due to the nature of indefinite divisibility of both, this set is only given to us synthetically, in that it skips over all the portions in between numbers, but does not exclude them in any logical manner. This logical need for synthetic operation to conceptualize the indefinite is done so because of the very inexhaustible nature of the indefinite in an analytical sense. This is not to say that the indefinite is not limited. It is, as the quantities within the variable sequence are fixed in identity. What allows us to surpass these limits, according to Guénon, is the transcendental operation of the synthesis of indefinite elements of a number or numbers, which, while skipping over the indefinite amount and letting us settle at a fixed one, still does not logically exclude them. When speaking of results in mathematics, we must do so with the use of synthetics, because they are speaking of determination. Guénon also states that this concept of synthetics can be applied outside the domain of quantity. They can be placed in the domain of quality, where one can see in the example of the distinction between what Guénon calls the principal order and the manifested order, or in other words, the world of being and becoming. The world of being and becoming are analogous to variable and fixed quantities. Variable in the sense that it is analogous to becoming because both are concerned with the domain of process and change, while the fixed would be analogous to being, as it is unchangeable and always remains in the same mode of existence. He ends this chapter by touching on the role of epistemology and how it plays into all of this, especially profane science, which is science that excludes all metaphysical possibility, which is inherently analytic because it concerns itself only with what is immediate. This is what leads to the conflation of the indefinite to be the same as the infinite, as this form of knowledge fails to see the metaphysical principles that are entailed within mathematics, denoting limit and unlimit. Synthetic knowledge allows for a holistic form of knowing because of its concern with the principle, especially regarding the notion of limit and unlimit. Analysis is concerned solely with appearance and not principle. Chapter 23. The Arguments of Zeno of Elea. Here, GUENON notes the synthetic brushing solves the paradox of Zeno. Firstly, we should outline what this paradox is. The paradox of Zeno postulates that if one is to pass from one point of a line to another, it would be an impossibility because the line is indefinitely divisible, and thus an indefinite amount of points would have to be crossed in order to reach the end, which would obviously never happen. The paradox is that this notion is contrary to all experience because we clearly can pass from point A to point B, no problem. The problem with this first paradox, according to GUENON, is that it has a wrong conception of motion, which is a passage from one point to another, and that motion is composed of a series of indivisible final elements which are indefinite. The other paradox, which states that motion does not exist because when an arrow flies through space, it is only ever in a position of stasis, as it can only be seen in one mode of being in each moment, so therefore it is not really moving, is also a problematic paradox. The basis of this statement is that we only see the arrow in each moment, so it only exists in each moment and can only be static in each moment. GUENON counters this by saying that we in fact do not see this when the arrow is flying. We instead perceive a singular motion and not the appearance of instants. GUENON states that the principle of motion presupposes a union of temporality and corporeality, as something cannot move without the presence of time as a precondition, and nor can it move without the presence of space as a precondition. The other paradox is essentially the one of Achilles and the tortoise, where the tortoise has a head start, and even though it moves slower by the time Achilles moves up to the starting point, he will never reach the tortoise or overtake the tortoise, because each time he catches up to a point the tortoise was at, he already moved on. The issue with these arguments is that they assume the movement is composed of a series of distinct points that all need to be crossed particularly. According to GUENON, we are here left with two options. Either these passages are continuous and therefore cannot be passed, or they are discontinuous and can be passed. GUENON states that since it is the case that we do and can cross these paths, this introduces a qualitative aspect into motion, which differentiates between the differing aspects of time and space, or what he calls qualitative heterogeneity. Chapter 24. The True Conception of the quote-unquote passage to the limit. Since limits are reached, it is, according to GUENON, important to have a proper and rigorous concept of the passage to the limit. We must here remind ourselves that limits cannot be reached by variables, as variables are the opposite of determination, and so only fixed quantities can bring us to the limit. The passage to the limit requires discontinuity of quantity, so therefore variability will not suffice to account for it. Also, it must be mentioned that the passage from variability to the limit, which is fixed quantity, is analogous to the metaphysical principle of the passage from potentiality to actuality, where potentiality is proper to indefinite variability and actuality proper to fixed ontologies. GUENON states that the means of the passage to the limit cannot come from within the indefinite variability, since because of its nature it is in this way inexhaustible, and thus it must come from without. This limitation on the indefinite variability is once again done through the usage of synthetic reasoning, which in a way transcends the indefinite variability by accounting for the fixed quantities within it, but at the same time also accounting for their indefinite elements. So when we have two fixed quantities, let's say we have a number line 1 and 3, we can represent it as 1 and 3 and not represent the indefinite numbers in between but still acknowledge their existence, I imagine in a form of potency in the Aristotelian sense. The passage from variability to fixity is analogous to the passage from the world of becoming to the realization of the world of being, as you are going from a state of change and flux to one of stasis. This passage from variability to fixity is not one of gradual movement from one unit to another. Rather, it is the immediate and abrupt one using synthetics to account for all the variability but not representing it. Chapter 25. Conclusion. GUENON ends this book by stating a few key points, namely that the issues within modern mathematics and profane science are a result of a lack of understanding of metaphysical principles. All confusion among modern mathematicians ultimately stems from the conflation between the ontologies of the indefinite and infinite, and the lack of ability to see their difference. The goal of this book is to solve the metaphysical flaws within mathematics as it is understood today. While throughout this book it is apparent that Leibniz gets many things wrong, Guénon does praise him for attempting to face metaphysical issues which many philosophers of his day refused to do. Only if Leibniz had a proper understanding of metaphysical principles could he be able to solve the quagmire he was in, and we have seen that his false notion of the passage to the limit in turn stems from his flawed notion of continuity. Guénon ends by saying traditional science and mathematics, because of its understanding of principles, gives way to realization, and this is why it is important to try and bring back these conceptions of the sciences and especially mathematics, as it is the most metaphysical science, so to speak.